Alright, we're going to look at finding the derivatives of our inverse trig functions. There are 6 of them, so here are 4. The other 2 are coming shortly. So the first one is if we want to find the derivative of our inverse sine function. So look at the notation. You see that -1 notation up there near the exponent. That's one way of saying inverse sine. Another way is to say arc sine. Alright, so our derivative here, now remember the rules for our general inverse derivatives, they always started with a 1 over. Okay, well this is not going to be any different. This is going to be 1 over, and then we're going to have a square root, and then a 1 minus x squared. Okay, I want you to remember and jot this down. The s in sine is like the s in subtract and the s in square root. Notice how we have a square root around this and there's a subtraction symbol in the bottom. Next up is our arc cosine, or inverse cosine. It's another way of saying that. Okay, and you'll see it used both ways, okay, depending on the author. The author of our textbook tends to use the inverse sine notation as opposed to arc, but a lot of times AP on their exams they will use the arc notation, so you want to be familiar with both. Well, this one's pretty easy to remember because it is the same as the sine's derivative, with the exception of it is negated. So it's -1 over the square root of 1 minus x squared. Our inverse tan function is next. Inverse tan is the same as arctan. Once again, this is going to be 1 over something. And in this case, it's going to be 1 over 1 plus x squared. Notice how it's very similar to the arc sine and arc cosine, except there's no square root and there's no minus sign. Think of this plus in there as like the plus in the t for tan. Okay. The next one is our inverse cotangent, also known as arc cotangent. Well, this is the negation of the tangent one. So -1 over 1 plus x squared. Okay, and now we have 2 more. Okay, next up is our inverse secant, also known as arc secant. So this one, once again, has a 1 over piece. And then we're going to have the absolute value of x in our denominator. And we're also going to have, next to that, multiplied to that, we're going to have, this is all in our denominator, we're going to have x squared minus 1, all underneath that square root. Inverse cosecant, also known as arc cosecant. Once again, this is just going to be like the other pairs here that we're noticing. Okay, it's just going to be the negation of what we have. Okay, so notice how secant, cosecant go together. Tangent, cotangent go together. And then sine and cosine. Okay, let's look at a couple of examples. Alright, so in this example we're looking to find the derivative of our function y equals inverse sine of 3x. So recall that the s in sine, well first we're going to have a 1 over piece. The s in sine is like the s in square root and subtract. Well, what we're subtracting here with our inverse sine is 1 minus, now I'm not going to literally write x squared. This angle piece is what we said before was quote-unquote x. So what we need to do here is carry along that angle piece of 3x and then square it. But we have to be careful because we're not completely done. This 3x on the inside is not just an x, so we need to chain along the derivative of that inside piece. So the inside piece is 3x, we're chaining along its derivative of 3, or its derivative which is 3. So our final answer is going to be 3 over the square root of 1 minus 9x squared. So don't forget about your chain rule. Okay, in our last example here, we are looking to find the derivative of inverse secant of 5x to the 4th. So this problem, recall if we're talking about inverse secant, it's once again going to start with a 1 over piece. Then we have the absolute value of whatever is on the inside, so whatever our angle is, and then times the square root. Our formula says x squared minus 1. Well, we're not going to literally write x squared. The x, like we said, is the angle. So you have 5x to the fourth quantity squared minus 1. And we need to remember our chain rule. We have to chain along the derivative of that inside piece. That's going to be 20x cubed. Now we can clean this up a little bit. We could take this 20x cubed, and then the absolute value of 5x to the fourth is just going to be 5x to the fourth. And so that'll actually divide into that. We can simplify it. We can do the 20 divided by the 5. That's going to leave us with a 4 up top. And the x cubed and then the x squared in the denominator, they will divide each other out and leave us with an x out in front. And then on the inside of our square root, we would have 25x to the 8th minus 1. So if this is multiple choice, this is what you're going to see for your final answer.